everyone, welcome back. In this particular video, we will be discussing the problem compute binary equivalent of a decimal number. So we will be given a decimal number as an input and we have to find out the binary equivalent of it. That is convert the binary, or actually not the binary, but from the decimal to the binary. So number system should be changed, but for that, obviously we should know what is a number system or what is a decimal number system and what is a binary number system. So what is the binary equivalent for decimal number 7? The binary equivalent for decimal number 7 is 111. How? The explanation is 111 means 2 raised power 0 plus 2 raised power 1 plus 2 raised power 2, 1 plus 2 plus 4, which is 7. That's why for 7 the binary equivalent is 111. So input will be any number from 1 till 1000, that is decimal number, can at max be 1000, can at min be 1, and corresponding binary number should be returned in the form of integral value. So it should be combination of zeros and ones, because we know in binary, what do you mean by binary? Binary means 2, that is either 0 or 1. So as we already know, decimal number system is what we have learned till now. It consists of 0, 1, 2, 3 up till 9. These 10 digits are there, and since 10 digits are there, every place value is nothing but 10 times the previous place value. What do you mean by that? If I am taking a number, let's say 500 or maybe 5432, how is this number calculated in decimal? We can say this number is 5000 plus 400 plus 30 plus 2. And what is 5000? 5000 is nothing but 5 into 10 is power 3 plus what is 400? 400 is 4 into 10 is power 2. What is 30? 30 is 3 into 10 is power 1. And what is 2? 2 is nothing but 2 into 10 is power 0. 10 is power 0 is nothing but 1. So we can multiply 10 is power 0 with it. Now what is 10 is power 0? 10 is power 0 means units place. It means units place. 10 is power 1 means the tens place. What about 10 is power 2? 10 is power 2 means hundreds place. And finally, similarly, the 10 is power 3 will be the thousands place. But in this number, in decimal number system, we take the place value as 10 times previous place value. Every place value is 10 times previous one. 10 is power 0, 10 is power 1, 10 is power 2, 10 is power 3, and so on. But when it comes to the binary number system, in a binary number system, first of all, there will be only two kinds of digits, which are known as bits, will be used. In decimal, they are known as digits, but in binary, we call them bits, either 0 bit or 1 bit. Only these two kinds of bits will be used. And what will be the number having place values? It will be having place value in twice only, because every place value, if we are adding, we are making the number twice of the previous number. So if I am taking a number as 1011001, how is this number calculated? We can say this 1 is nothing but having 2 into 2 raised power 0, that is 1 place value, units place value. But this is having 2 raised power 1, 2 place value, 2 raised power 2, 4 place value, 2 raised power 3, 8 place value, 2 raised power 4, that is 16, then 2 raised power 5, 32, 2 raised power 6, 64, and finally 2 raised power 7, 128 place value. So all these numbers, all these bits, zeros or ones, will be having place value as twice the previous place value or 2 times the previous place value. So the main question is, obviously this number is not equivalent to this number, but the question is how we will figure out the corresponding binary number of a given decimal number. So for that, we have to convert the place values from 10 to 2, that is 2 raised power 0, 2 raised power 1, 2 raised power 2, and so on. And in order to get these kind of place values, obviously we need some kind of division by 2. Then only we will get the place values in terms of 2. That is, we will be dividing the input number by 2 every time, because the required number is binary, and binary have 2 kinds of digits, or you can say it is base 2 number. We are converting base 10 number into a base 2 number. So we will be dividing the input decimal number by 2 every time. It will either give me 0 remainder or 1 remainder, and that is what is going to become the digit, or you can say the bits for the resultant. So let's just try it for 52. If I take input as 52, 52 is the decimal number. We want to convert it and find the corresponding equivalent binary number. In order to solve it, what we are going to do, as discussed, we are going to divide it by 2 every time, because division by 2 will give you either 0 remainder or 1 remainder. and it will give you the decimals or the digits actually, or the bits actually, you can say, in terms of 2 2. That is either 0 or 1, or you can say every place value will be twice the previous place value. So I'm making some tables in order to do the division, and then we will do the complete proper divisions. So this will be the input number. Let's say this is your input number n, which is 52 initially. We want to divide it by 2 always, and we will also write the remainder. Let's just write the remainder here for now during try run. So when we will divide 52 by 2, what will be the new remainder, or what will be the remainder when we will divide 52 by 2? It will be 0. 52 is an even number. Even numbers on dividing by 2 will give you 0 remainder. Let's just say this is numerator, and let's just say this is denominator. We are dividing 52 by 2. What will be the new quotient? 52 by 2. If we are dividing, the quotient will be 26. And I will again try to divide it by 2. We will keep on dividing by 2, 2, 2 till the number reaches 0. So 26 by 2, I will say again the remainder is 0. And 26 by 2 will give you quotient 13. So quotient will become new numerator. Denominator will remain same. 13 by 2. Now 13 can't be divided properly by 2. It will give you one remainder. And what will be the quotient? The quotient will be 6. 6 into 2 plus 1 is nothing but 13. 6 into 2 plus 1 is nothing but 13. So now divide by 2 again. 6 by 2, the quotient will be 3. 6 into 2 is 3 plus 0 will be the remainder. Finally, not finally, but now we will again try to divide. And if I will again try to divide, what will be the remainder on dividing 3 by 2? It will be giving you one remainder, and 1 will be the quotient. 2 into 1 plus 1, that is 2 plus 1 will be 3. Is 1 also what we can divide? Yes, the answer is we can divide it by 2. It will give you one remainder, and it will give you 0 quotient. 2 into 0, 0 plus 1 is nothing but 1. And as soon as the numerator becomes 0, now we can't further divide. Even if we divide, it will always give you 0, 0, 0, 0. So no need to divide further. So all these bits are what you are getting as the output. But how to arrange them? Like how to form the output? Should we form the output as 1 1 0 1 0 0, or should we form the output as top to down? That we can easily confirm by just writing both the numbers and doing the expansion using place values. Let's just try first of all top to bottom. So if I am trying top to bottom, let's take different colors. So for top to bottom, I am taking blue color, and for bottom to top, I will take yellow color. So first let's find out top to bottom. That is 0 0 1 0 1 1. What will be the corresponding decimal number? The decimal number will be, you can say, 1 into 2 raised power 0, 1 into 2 raised power 1, 0 into 2 raised power 2. So 0 into anything will always be 0. So no need to take it. And then 1 into 2 raised power 3. This is 2 raised power 0, 2 raised power 1, 2 raised power 2, 2 raised power 3. So what is this number? This is 1, this is 2, and this is 8. What is the number coming out to be? It is coming out to be 11, but input number was 52. So obviously top to down is wrong. It is not correct. But if I will try bottom to top, that is first I will take 1, then 0, then 1, then 0, 0. And if I will find out the corresponding decimal, for this number decimal was 11. This was the decimal number, that is base 10. But if I will figure out base 10 for this, it will be 0 into 2 raised power 0, 0. 0 into 2 raised power 1, again 0. 0 into anything, always 0. 1 into 2 raised power 2. 2 raised power 0, 2 raised power 1, 2 raised power 2. 2 raised power 3 will be 0. 2 raised power 4 will be 1 into 2 raised power 4. And then again 1 into 2 raised power 5. So what will be the output? Output will be 4 plus 2 raised power 4 is nothing but 2 into 2, 4, 4 into 2, 8, 8 into 2, 16. And then 2 raised power 5 will be 32. So what will be the sum? Sum will be 20 plus 32, which will be 52. And that is what we require. That is what was the input. So the correct output will be take the numbers from bottom to top. But how actually we can take the numbers from bottom to top? Because first remainder we will get 0, then 1. That is, we will always get it from top to bottom only. We can do it in order to store it in the form of bottom to top, but traversal will still be top to bottom. Either we can use strings and then convert that string data structure into integer by using some inbuilt functions like stoi in C++ and similarly other functions, maybe integer.parseInt in Java. But the main thing is, can we do it without strings also? The answer is yes. What if I am, let's say, storing the resultant as an integer only? What that is what we have to return, which will be initially 0.
what we will do is, as soon as every remainder comes, we will do something with it. That is 0. We will add it in the resultant. 0 plus 0 into 10, so that it is shifted in the right hand side. We always want the previous remainder to be in the right hand side and new remainder or the new number which is coming either 0 or 1 to be in the left hand side. So I want this number to be in the left. That's why I'm multiplying it with 10. So 0 into 10 plus 0 will be 0 only. But next number again 0. 0 plus 0 into 10, you will still say it is 0. You will say what is the difference? The difference will be clear to you. The point is, we don't want the previous number to be the same, to be the having same place value. That's why we are making it multiplied with 10. Now a new number is coming, which is 1, and we want it shifted one side to the left. And in order to shift it one side to the left, now we actually don't want to multiply it with 10. We wanted to multiply it with 100. So the main game is, the first number was not multiplied with 10. It was multiplied with 10 is power 0, or you can say 1 only. Next number was multiplied with 10. And now the next remainder 1 is going to be multiplied with 100. That is 10 is power 2. Let me write this 10 is power 2. So it will be 100 plus 0, that is 100. And now the game will be easy. 0 is coming. What will be the place value? 100 into 10, 1000. So 100 plus 0 into 10 is power 3. What will be the number? It will be nothing but 100 plus 0 into something is 0. So 100 plus 0 into something is still 100 only. Next number, it will be having place value what? A bigger number. It was 10 is per 0, it was 10 is per 1, it was 10 is per 2. This is just to form a number in integer. Do not get confused that we are multiplying 10 is per 0, so these place values are 10 is per 0 or no, they are 2 is per 0 only. 2 is per 0, 2 is per 1, 2 is per 2, and so on. Just to form a number, we have to multiply it with 10 so that it can get the next digit, or you can get the next place value in the form of integer. Integer means a decimal. So what we will be doing, we will be multiplying 1 with 10 is power 4 and adding the previous number. That is 100 plus 1 into 10 is power 4. So what is 1 into 10 is power 4? 10,000. 10,000 plus 100. 10,000 100. 10100. Or you can also say 10,100. That's why we need it in integer. That's why we are multiplying with 10 to shift the digits. And finally, 1 into 10 is power 5 plus the previous number. That is 10,100 plus 1 into 10 is power 5 will be 1 lakh, and 1 lakh plus 10,100 will be 1 lakh 10,100, or you can say 110,100. 110,100. That is what we require. That is the output. So in this way, we can form the output in the integer, the binary number, binary equivalent of the input number. So with that, we have actually come up with the approach which we are going to do. That is, keep on dividing the input number by 2. Why? Because we will always get a remainder 0 or 1. In that fashion, we will be able to convert the input number in base 10 into the output number in base 2. That is, every place value will be twice the previous place value. This is the approach. What is the time complexity? Since we are dividing the input number by 2 every time, input, let's say, is n by 2, by 2 4, by 2 8, by 2 16, and so on up till 0. So how many terms are there, or how many divisions are taking place? There are logarithmic divisions going to take place. If you know about logarithms, you can easily know that why these number of terms are logarithmic. If you do not know about logarithms, what I can do is, I can take a number 64. For 64, how many iterations it will take, or how many divisions it will take to reach 0? 64 will become 32, 32 will become 16, 16 will become 8, 8 will become 4, 4 will become 2, 2 will become 1, and 1 will finally become 0. So how many iterations? 1, 2, 3, 4, 5, 6, and then finally the last iteration 7. What is 64 in terms of 2 raised power anything, or 2 raised power something? We can say 64 is nothing but, I guess, 2 raised power 6. Why? Because 2 into 2, 4, 8, 16, 32, and 64. It is 2 raised power 6, and 6 are the number of iterations taking place. So this 6 is nothing but log base 2 raised to 6, or log base 264. So the number of terms for this division will be logarithmic of n, log base 2 of n specifically, or you can say time complexity will be logarithmic in nature, almost, which is usually constant. Why? Because input number is very small. Input number can be at max 1000. So log of 1000 will be very, very less. So you can say it is almost going to be constant. What about space? since we are just going to make an integer takes usually 4 bytes in all of the programming languages. So space is constant, a single integer is there. So almost constant time, constant space solution. Now we will be actually writing the instruction manual or the pseudo code. First step, let's initialize, set the resultant integer as 0, in which we are going to store the binary number. The input number we have to keep on dividing till it becomes 0. So let's run a while loop till n becomes 0. Up till it is greater than 0, we have to run the while loop till n is greater than 0. As soon as it becomes 0, then we have to stop, because 0 always will give you 0 0 0 remainder, and no matter how many zeros you can append in the front, the answer will remain same, because zeros in the front are nothing. They are like prefix zeros, just we can ignore them. So what we have to do is every time take the remainder, get the remainder of what? Of n modulus 2. Get the remainder of n dividing by 2, divided by 2 in a remainder variable or in a digit variable. Let's say get the remainder of n by 2 in bit variable, because these are nothing but known as bit. What we will do with this bit is we will multiply with a power number. Power initially will be 10 to the power 0, or you can say place value number. Place value will be initially 10 to the power 0, which is 1. 1 into 10, 10 into 10, 100, 100 into 10, 1000, 1000 into 10, 10,000, and 10,000 into 10, 1 lakh. So every time the power will get multiplied with 10. So we will initialize one more variable, which is power. Set power variable, or maybe you can say the place value variable, place integer as 1 initially, 10 to the power 0, which is 1. What we have to do to form the resultant? Resultant will get updated as update resultant as the previous resultant plus the new number, that is the bit value, but this bit value should be multiplied with the place value, that is 10 to the power 0 or 10 to the power 1 or 10 to the power 2 and so on. And every time place value will get updated by 10. So multiply place value with 10. Multiply, or you can say update place value as place value into 10. But one more thing, if we are making 52 by 2, next time we should not again make 52 by 2 division. We should make 26 by 2, 13 by 2, 6 by 2. So we have to divide n actually. Before dividing n, we were getting remainder, but now we should actually divide by 2. So divide n by 2. This is the updation. Divide n by 2. Every time we will update the n value. Finally, whatever the resultant will be, we will return that resultant after the loop. That is once the number, decimal number becomes 0. So this entire code, now we will be doing the inline expansion of the instruction manual to write the code in Java programming language, although the code will be very similar in all of the languages. And we will also write some test cases to ensure that whether the code is working fine for corner scenarios also, boundary scenarios also, and discuss about time and space. So initially what we need the resultant, which should be returned as an integer. So we'll initialize the resultant also as 0, so that we do not have to typecast, convert the data structure from string, or you can say the data type from string to integer, from anything long, anything other than integer to integer. And also we need a multiplier, a place value, because every time the new digit is coming or the new bit is coming, we are actually multiplying that bit with 10 to the power 0 or 10 to the power 1 or 100 or 1000 and so on. So initially place value will be 10 to the power 0, which is 1. We will run a while loop till the point the n variable is more than 0, because as soon as the n becomes 0, we have to stop. There is no more division which we can have, or there is no more new remainders. Always it will come at prefix zeros. We will get the remainder by dividing n by 2. So remainder will be stored in a bit variable. So int bit is equals to n modulus 2. What should we do with this new bit? Either 0 or 1. Add it into the resultant, but in the front side. That's why we are using resultant plus bit into place, not just simply resultant plus bit. Simple addition will not work. So update the resultant as the current resultant plus the new bit remainder into the place value, corresponding place value. That is 1, 10, 100, and so on. And for the next time, place value will get 10 times the previous place value. That is, place value is nothing but place value into 10. And also, if I will not update n, this loop will go into infinite loop, infinite iteration. Why? Because every time n will be more than 0 and we are not updating n, but we have to divide n by 2 every time. So n will be equal to n by 2 every time. And finally, we can return the resultant. So let's just see whether the code is working for some sample test cases. For 7 integer, the output binary equivalent should be 111. Let's see if it is giving me 111 or not. It is taking time to run. Yes, it is giving me the same output. Let's do it for 52. That is the test case which we took during the dry run. It should give me 110100. Let's see if it is giving me 110100. Yes. What about some corner cases? Let's say if input integer is 1, decimal 1 is equivalent to binary 1, or decimal 0 is equivalent to binary 0. So 1 should give me 1 only. Let's see if it is giving me 1. Yes. Same goes for 0. Although 0 is not within the constraints, but let's try for 0. What will be the output for 0? Again, it is a 0 only. What about the biggest number, 1000? Let's try for 1000. Will it be in integer range or not? Because return type is only integer. Let's see. If it is running code, it is taking some time and it is within the integer range. Like you can see some number of digits, 1, 2, 3, 4, 5, 6, 7, 8, 9. You can say, let me just again count 3, 3, 3, 6, then 9 and 10. So almost within the integer range. So that is the biggest number which will have a binary equivalent as an integral value, or within integer range, within less than 10 2 raised power 32 minus 1. So let's just submit it and see if all the test cases are passing or not. It is taking some time. Hopefully it should pass all the test cases. Yes, all 13 test cases are getting accepted. But what was the time complexity as we discussed in the approach? Since we are every time dividing by 2, n by 2, n by 4, n by 8, the total time complexity will be logarithmic of n, log base 2n. And the space complexity, since we are not taking any extra space, we are not taking any extra data structure, auxiliary data structure, the space will be order of 1, that is constant. So linear, or actually not linear, but logarithmic time constant space solution for the problem convert binary equivalent of a decimal number. With that, we have done all the milestones and the problem also. We will come up with a new video where we will discuss new problems. But till then, bye bye. Take care.